let's try an example with this dot product stuff. So we're going to do example 1.46. So it says, find the scalar product, also known as the dot product, of the two vectors a and b given in the exercise previously. They're listed below, and find the angle between those two vectors. So vector a is 4i hat plus 7j hat. Vector b is 5i hat minus 2j hat. Another way to write this would be plus a negative 2j hat. And that might help us here to kind of make sure we use the correct term when we put these together. So for our dot product, we got to decide which equation should we use. Should we use the magnitude and the angle between, or the components? Well, because they gave me components here, I'm going to use the component method. So in order to do the dot product of these, so a dot b, what we're going to do is we have to take the two x's and multiply them together. So 4 times 5 plus the y's multiplied together, 2 times, or negative 2 times 7. Now, when we do this, notice the I hats and j hats don't come here because it is a scalar product. And so we get 20 and negative 14. So we end up with a total of 6 as my dot product. And there is no direction on this dot product. That's why it's called a scalar product as well. All right. So they also want me to find the angle between them. Now, this is a little more intense because I know what the dot product is. I know this value is 6, but I want to find this angle. So I'm going to need the magnitude of each of these. So what I can think about is this is a 4 and a 7. So it's going to have a magnitude A. And so I can do a little bit of Pythagorean theorem here, and I find out that A is going to be 8.06. And I can do the same thing down here. We have 5 and 2, and do a little Pythagorean theorem, and I get B is going to be 5.38. Okay? And so now I can use this method. So I have 6, I'm sorry, the top one here. 6 is equal to 8.06 times 5.38 times the cosine of the angle between them. And so what I can do then is I can say, okay, let's solve for theta, or phi in this case, I'm sorry, phi. And we end up with an angle of 82.1 degrees, being the angle between them. Now, a cool side note about dot products, if the angle between them is 90 degrees, so if this phi is 90, the dot product is always 0. So we're darn close though, 82 degrees. All right, there you go.